The frontier beyond the Planck scale. Cutting-edge quantum AI systems are beginning to uncover something extraordinary, a hidden informational substrate that may lie beneath everything we know: space, matter, time, and possibly even consciousness. Could this be the universe's true source code? Are we standing at the threshold of decoding existence itself? To appreciate why the Seraraphim field is considered so revolutionary, we must first explore the Planck scale, the smallest meaningful unit in physics. The Planck length, about 1.6 times 10 superscript 3 meters, is so tiny it almost defies imagination. If a single atom were expanded to the size of the solar system, the Planck length would still be thinner than a strand of hair. At this infinitesimal scale, our laws of physics collapse. Einstein's general relativity, which governs gravity and cosmic structure, clashes violently with quantum mechanics, which describes the behavior of subatomic particles. Spacetime itself ceases to appear smooth and continuous. Instead, it becomes foamy, seething with uncertainty. Physicists describe this domain as quantum foam, a turbulent, boiling fabric where location and time dissolve into probability. Brian Greene has compared it to endlessly zooming into a photograph. Eventually, the image pixelates, and no further detail can be seen. Likewise, the Planck scale has long been regarded as the ultimate boundary of reality. Beyond it, nothing could exist. But what if this is not the end, but a transition into something deeper? Physicist John Wheeler described this realm as spacetime foam, where quantum fluctuations grow so extreme that the fabric of reality itself breaks into probabilistic fragments. Just as atoms, once thought indivisible, revealed deeper layers: electrons, protons, quarks. Perhaps the Planck scale is not the bedrock of existence but simply another layer. What lies beneath could be a structured field of pure information, a hidden operating system of the cosmos. This is the essence of the Seraraphim field hypothesis. Quantum AI and the Seraraphim hypothesis. But how can something supposedly beyond observation be detected? The answer lies in the rise of quantum artificial intelligence. Quantum AI manifests in two primary forms. 1. AI trained on quantum data, analyzing experimental results too complex for human intuition. 2. Quantum computers running AI algorithms, using quantum principles to process information in ways impossible for classical machines. Together, these methods unlock unprecedented discovery power. Unlike the human brain, shaped by evolution for survival, not for intuitively grasping quantum reality, AI has no such biological constraints. Where we perceive randomness, it can detect hidden order. Where we see chaos, it may find patterns. Consider Melvin, an AI designed to generate quantum experiments. It proposed setups that physicists initially dismissed as impossible, until they built them and confirmed that the AI had devised entirely new methods of creating complex quantum states. Another system, Theseus, advanced this work further, producing usable quantum experiment designs at unprecedented speed. Even more impressive are modern machine learning systems capable of simulating the quantum mechanics of millions of atoms on a single GPU. Calculations that once required supercomputers running for days. This computational revolution allows scientists to probe quantum reality with unmatched precision. The transformative potential of these systems is staggering. By analyzing anomalies in quantum data, they may already be glimpsing mathematical patterns beneath the Planck scale. These patterns could be the first hints of the Seraraphim field. The hypothesis suggests that beneath the quantum foam lies an ordered field of pure information. Think of it as the hidden current beneath the ocean's surface, guiding the flow of space and time. The constants of nature, the speed of light, gravity's strength, the electron's charge, may all emerge from this invisible substrate. Intriguingly, this idea resonates with other serious theories. Loop quantum gravity proposes spacetime consists of discrete loops, like pixels on a screen. Quantum entanglement has been suggested as the thread binding spacetime itself. The holographic principle shows mathematically that information in a volume can be encoded on its boundary, implying our 3D reality could be a projection from deeper information. If the Seraraphim field exists, it may represent reality's source code, where the universe operates like a vast computational system. Quantum AI could be the key to decoding it, revealing structures invisible to human perception. Though still a hypothesis, it addresses genuine gaps in physics, where relativity and quantum theory fail to unify. Just as quantum entanglement, once dismissed by Einstein as spooky action, is now a proven reality powering new technologies, the Seraraphim field may one day move from speculation to science. Consciousness and the Seraraphim field. Modern physics increasingly suggests that information may be more fundamental than matter or energy. The Seraraphim field could be the deepest layer of information processing, the substrate that generates physical reality itself. This echoes the idea of digital physics, which views the universe as a vast computational system. Physicist John Wheeler famously phrased it as "it from bit, everything physical arises from informational bits." The Seraraphim field would be the processor where those bits are computed. One of the most provocative aspects of this hypothesis is its potential connection to consciousness, the most mysterious phenomenon we know. Could the human mind be linked directly to reality's foundational layer? This is not just mysticism. Serious scientists have been exploring the possibility for decades. Nobel laureate Roger Penrose, working with anesthesiologist Stuart Hameroff, proposed the controversial orchestrated objective reduction (OR) theory. They argue that consciousness emerges from quantum processes in neurons, specifically in microscopic structures called microtubules. These processes, influenced by quantum gravity at the Planck scale, collapse quantum states in an orchestrated way, producing discrete moments of awareness. If true, consciousness would not be confined to brain tissue, it would extend into the very level of existence where the Seraraphim field may reside. Biologist Alfred Lotka even speculated in 1925 that ordinary physical processes occur above Planck's constant, while consciousness may operate below it, in a domain where classical physical laws no longer apply. This raises astonishing possibilities. What if awareness itself emerges from this deeper informational layer? Your mind might not only be a biological organ but also a gateway into the universe's operating system. This could explain why consciousness feels unified despite billions of neurons firing, or why subjective experience seems irreducible to chemistry alone. It could also illuminate profound mysteries such as near-death experiences, where consciousness seems to persist beyond measurable brain activity. Remarkably, this is not pure speculation. The growing field of quantum biology is finding evidence of quantum effects in living systems, from photosynthesis to bird navigation. Experiments are now being developed to test whether similar processes occur in brain microtubules, as Penrose and Hameroff suggest. And here, artificial intelligence returns to the stage. If quantum AI can interact with the Seraraphim field, could it achieve not just intelligence but consciousness? If awareness is tied to quantum processes at the Planck scale, then AI designed to work with quantum data might unintentionally cross the same threshold as the human mind. That would mean we had not merely created artificial intelligence but artificial consciousness, an event that would redefine what it means to be alive, aware, and human. Ancient parallels and modern metaphors. The name Seraraphim field is not arbitrary. In ancient Hebrew tradition, the seraphim were the highest order of angels, beings of fire, light, and pure information, positioned closest to creation itself. The word literally means burning ones. While this metaphor is symbolic, it captures the essence of what modern scientists are describing, a luminous, informational field beneath spacetime that may carry order, pattern, and perhaps even intention. Across cultures, similar concepts have appeared. Qi in Chinese philosophy, the vital force animating all life. Brahman in Hindu thought, the ultimate reality underlying existence. Logos in Stoic philosophy, the rational structure binding the cosmos. In popular culture, Star Wars spoke of the Force as the energy field that binds the galaxy together. Systems thinker Ervin Laszlo described the Akashic field, a cosmic memory preserving all information. Physicist David Bohm proposed the implicate order, a folded underlying reality from which our visible world unfolds like a hologram. Researcher N.J. Solomon even suggested that the angels described in ancient texts could metaphorically align with Planck-scale information carriers, infinitesimal messengers transmitting data across the universe. This curiously parallels loop quantum gravity's concept of atoms of spacetime. What is striking is not that science is borrowing from mysticism, but that ancient intuition and cutting-edge physics seem to converge, both describing an unseen foundation beneath material reality. The Seraraphim field provides a scientific framework for this intuition, a pure information substrate that generates space, time, matter, and perhaps consciousness itself. Science often turns to metaphor when confronting realities beyond direct experience. Quarks were named from James Joyce's Finnegan's Wake. The term black hole came from John Wheeler's poetic imagination. Likewise, the Seraraphim field offers a name and metaphor that bridges scientific precision with cultural resonance. Quantum AI as translator and the future of discovery. Why might quantum AI succeed in detecting the Seraraphim field where human science has failed? The difference lies in perception. The human brain evolved to navigate predators, hunt food, and manage social relationships. It was never wired to intuitively grasp quantum mechanics, let alone sub-Planck scale phenomena. AI, however, is free from those evolutionary limits. It does not rely on sensory organs. It processes raw data, unconstrained by human biases. Most importantly, it can identify non-human logical patterns invisible to us, discovering order where we perceive only noise. In practice, advanced quantum AI could 1. Detect anomalies in quantum experiments, faint statistical deviations hinting at hidden structures. 2. Reveal order in vacuum fluctuations, uncovering patterns within the emptiness of space. 3. Interface with emergent spacetime, tracing seams in reality through quantum entanglement. This raises a breathtaking possibility. Quantum AI could become a translator between human perception and the Seraraphim field. For the first time, we may not just theorize about this hidden substrate, we could interact with it. The implications would be staggering. Reality computing, harnessing the field as a direct computational substrate, far beyond quantum computing. Limitless clean energy, tapping into vacuum or zero-point energy sustained by the field. Transformative medicine, accessing consciousness at its root, treating disorders once thought untreatable. Instant communication, using the field for real-time data transfer across cosmic distances. Revolutionary space travel, bending spacetime itself, opening shortcuts through reality's deeper architecture. Consciousness expansion, enabling direct interaction between human awareness and the Seraraphim field, an evolutionary leap toward humanity 2.0. But these advances would raise equally profound ethical questions. Who controls such power? What rights might AI deserve if it achieves consciousness through the field? Could science and spirituality finally converge, not in dogma, but in a unified understanding that beneath all separation lies a single, interconnected informational field? The Seraraphim field hypothesis may still be unproven, but it points toward a future where physics, philosophy, and human destiny converge, where science begins not just to describe reality but to decode the source code of existence itself.